Hello, hello, good morning. I am ready to jump back into the Rust Standard Library. I started watching a little bit of that video that I mentioned yesterday, John Gangset's pinning video. So far, what we've learned from like pin and unpin. Well, first of all, for unpin, let me go back. So far, what I've learned is pretty much everything gets unpinned. Like almost everything from the standard library. And then pin is often used with async await, so futures and that kind of stuff. And that's one of the reasons why I was having trouble figuring out something that can like properly do pin, because if you do something that can like be safely moved around and you pin it, it doesn't really matter. It's gonna automatically unpin when I go and try to use it. So it's like, I'm really figuring it out. Like unpin doesn't really matter quite as much as pin does. So obviously I haven't gotten too far into the pin part of it, but knowing that it's a futures thing is going to be interesting, because I wonder how much of the standard library goes into futures too, or if that's more of like a core thing, or if we, I don't know. It's going to be interesting. But that's why we have on hold until we learn something else. Until then, so I guess like right now, on hold until we learn. Right now it's futures, and watch. I guess it's just futures. We'll deal with that later. Until then, we're going into borrow. So we actually have some borrow stuff here already. Yeah, we've actually done borrow already. When we're using borrow, the borrow items will have the same traits. Right. It's part of like convert as ref. Yeah, so we've done this. And we're able to do an interesting borrow for like essentially the same thing that you do for like a hash map, where we took a wrapper around a string and we were able to get the string out, as opposed to, you know, just borrowing the wrapper. Borrow mute, we've done this one also. It's pretty much the same thing, except it's mutable version. Okay, so convert from, we haven't done this one yet. Come on, let me move you. Oh, it's just from. It's convert from the convert module, the from, and this is a trait. Yeah, here we go. So this is the one we're caring about here. Okay, so used to do value to value conversions while consuming the input value. It is the reciprocal of into. So reciprocal of into. Man, I still have something written out here and I still managed to misspell reciprocal. Ooh, I don't, do I have into? Into is a trait, right? Yeah, okay, convert into. Convert into. There it is. Okay, so reciprocal of convert into. This also consumes. So it consumes the input value. One should always prefer implementing from over into because implementing from automatically provides one with an implementation of into. So I think that's something that we've seen before when trying to program. We were like, oh, let's just do an into, and then Clippy got angry at us saying, hey, why are you doing this? Just do from. So implementing from gives us into for free. Basically going the opposite direction. Is it going out? No, I don't think so. It's still the same direction. Only implement into when targeting a version prior to Rust.141 and converting to a type outside the current crate. So that's interesting. Almost all the stuff that I'm going to be working on doesn't have that limitation. And we're on Rust.155 now, I think. From was not able to do these types of conversions in earlier versions because of Rust orphaning rules. Prefer using into over using from when specifying trait bounds on a generic function. This way, types that directly implement into can be used as arguments as well. I mean, it sounds like this type of stuff should be things that goes into. The from is also very useful when performing error handling. When constructing a function that is capable of failing, the return type will generally be of the form result. The from trait simplifies error handling by allowing a function to return a single error type that encapsulate multiple error types. See the example section in the book. Okay, so So the from trait allows you to do a generic error. But if I take a look at this, it doesn't look like it actually returns a result. That's interesting that they mention this, but they don't. From doesn't return a result, right? Yeah, it returns itself. So from cannot fail. From cannot fail. If it would, then can it. Or use. Oh, or then try from. Then use try from instead. Yeah, so let's see, generic implementations. From T for U implies into U for T. Yeah, okay, that makes sense. From is reflexive, which means that, okay, yeah, it's backwards compatible, so like the other direction is also something good. String implements from stir. Okay, so let's see. An explicit conversion from a stir to a string is done as follows. We can't necessarily do this on string ourselves, but what we can do is wrap string and then create our own version of that. So let's do that. In our examples, we're gonna have a from. So what is this actually? This is convert from. My naming convention is Not the best here. Keep on changing things around. Okay, so let's say we have like a string wrapper. So struct my string, and you simply wrap around a like string, which is going to be a string. So pretty simple, right? Now, if I want to convert this into a stir, we can do impl from stir for my string. Implement the missing members here. Okay, so we have our input from, which is a stir. Okay, so from a stir, we're gonna create this my string. So this is gonna be our like string here. And so creating this is pretty simple. At this point, we're going to consume this stir. It's also from a string slice. So I don't know if you can really consume that or not. We're gonna return a self string. But we're gonna take this string and to owned it. And that now allows us to do the thing. So we should be able to do now let my string equals, let's see, I should be able to do this, right? My string from, and then just like put in this stir. So hello world. Oh, and if I want to debug this, what am I doing? Debug, derive, debug, and then here we do debug. Okay, so if we run that, yeah, we're able to create that string that way. So it's like really simple the way we can now like take that in, and we can like really do anything from this. If I want to do something silly, because why not? What if I create like this my string? So my string, oh sorry, impl my string, impl from, and then I'm gonna bring it in from like an int. Yeah, let's do an int. So like an i32 for my string. So if we take our input here, which is this i32, whatever that really means. Now I can create that using format. So we can do self string. We could then do a format here, and we can just say give me that. So I might have my string there, but I can also set like my custom int is equal to string from. Now you can take unknown, because now I can take multiple things. So let's give it an i32 here, which I think is default if I just give it any number. So if I just say like 10. And I run you, then I also get that. So it like appropriately uses the right one based upon this type. It's actually really cool and really nice. But theoretically, I can now do into for this as well, just for free. So let's say I want to create a my string. So I give it the type here. If I have a function, maybe it's like on the signature. Actually, that might be helpful here. Let's do a function create my string. I don't know what I would take in. I can take in like a T. I don't know how to restrict that yet. So this might not work. We have our input, which is this T. I want to return a my string. So really, I just want to do a input dot into. Yeah, we need to properly restrict this. I don't know if I can restrict like from a from. I can only restrict on traits. This is not a good example. Here we're gonna do this one. So we have this my string. So that I can just do like a 10 dot into. And that should still work because it knows that it's going into a my string here. So that I can still custom debug this. Now it's a little bit weird to do that, but it works. So we get this for free essentially. While performing error handling, it is often useful to implement from for your own error type. Okay, so the idea is that you do from for your own error type. By converting underlying error types to our own custom error type that encapsulates the underlying error type, we can return a single error type without losing information on the underlying cause. The question mark operator automatically converts the underlying error type to our custom error type by calling into, which is automatically provided when implementing from. Okay, so I think this is where it gets really fascinating and really interesting. Let's say I do have like a custom error type. So we're gonna use this error. Actually, I don't think I need to pull it in there. We can just do it down here. So let's create that custom error type. So we have struct. Oh, it'd be enum. So we have our super awesome custom error. We're going to derive, debug, and this error. Now you're gonna yell at me because I need to now have, I think it's error equals, no, error like this. Okay, super. Okay, so now we have this custom error. Now I need something that can give us an error. Those are other options. Like, so if I do Hashmap stuff, gives us an option, not a result. We can try to read something from disk. That can give us an actual error. I can get one from strings, right? If I try to do a convert. A try into can work. Okay, so let's say that I have an actual string. So that real string equals string from, so hello. So I have this. What can I do with real string that can potentially give me an error or a result at least? I can parse it. I can parse it. Okay, so let's parse it. Now, hello is not parsable. That's not going to become a number. Parse the string slice into another type. Oh, I have to give it the type that I'm going into. Okay, so I'm going to parse you into an I32 because we know that hello and I32 is compatible, right? Totally. So we're going to get this result with an F error. What type of error is that? It's just an F or an, okay, so this type F error, which is an unknown. So I want to do a into. So if I return custom errors, I guess this would have to be a result. Custom errors here is what we're returning. So I question mark u to let converted equals. Now I'm sort of expecting this to fail. Okay, so we couldn't convert the error to custom errors. The question mark operation explicitly converts a conversion using the from trait. Okay, so we're going to do from. Okay, here we go. So standard ops from residual. Result, convert infallible. Okay, so I think it's this parse int error that we need to do. So a parse int error. So let's do a impl from parse int error for custom errors. Okay, so if we get this error, I just want to give it the super awesome custom error instead. So we're going to do a self super awesome custom error. Okay, and let's try just returning okay like that. You're happy. So I guess we are just sort of ignoring that error here. We don't really care about it. We're just converting it into this. So if I run this, we should see this super awesome error printed out. Error, super awesome custom error. Now it didn't print out the sort of like way we were expecting it to, but that's because we're not doing the right kind of error. So let's bring in we can do anyhow error, or sorry, anyhow result, I think, for this return. And so you're going to be that. And now I think we're going to get a better printout. We got this invalid digit found in string. That feels like it didn't work the way I wanted it to. We got the super awesome custom error before, so it doesn't actually do this for me. No, let's go back. Yeah, so here we got this error, super awesome custom error. Oh, because when it does the from, the into for this, it didn't know. Like it actually just converted into an error that that anyhow could handle. But when I don't have that and I just do my custom errors, I get this. So I have to have like a little bit more explicitness with this type here, and I don't get any of the benefit of using something like error or anyhow or like the entire this error thing for like this this display. But it's nice. So I could have the error. I don't think I even need to do this. I don't need to derive you. I don't need to do that. We could just have this custom errors like that, and we're returning custom errors, and the into just works for it. Still the same exact thing. So if you don't want to use this error and you want to not just have strings around and you still want to have like an enum, this is a way to do it, which is actually really nice. I kind of like this. I'm probably still going to use like an anyhow type thing or like this error, because it is really nice having those descriptive errors, but in a pinch, this might be really nice too, especially since when I'm doing stuff like GGEZ or some other engines, I can just convert them into whatever error I want them to be. All right, that's also okay. We only have one required methods. That's this from. So consume the input. So I mean, I guess like there's a couple things for this from here, which is set, like we want to set the from, like from takes in the type given in the impl, and then oh, come on. Consumes it, then returns the new thing, like the thing that is being converted into. And then all the implementers that we can see here. Okay, nice. So that brings us to into here. Which we know is like the opposite of from. So I don't actually know if we need to go too deeply into this, because this is basically just automatically given to us. Exactly, it's the opposite of from. So it's also, one should avoid implementing into and implement from instead. Okay, so that's the like the big thing here. So if we can implement convert from, and we should, because that is a much better choice here. From will give us an into implementation for free. Prefer using into over from when specifying trait bounds on generic functions. That therein lies, like, that's the big thing, which is use into when specifying trait bounds on a generic, I guess like the generic types. So generic types. To ensure that types that only implement into can be used as well. This trait must not fail. So then we want to use try into. Okay, generic implementations. Okay, so from T for you implies in. Okay, so all of that same thing from. Implementing into for conversions to external types in old versions of Rust, because that's kind of like the only reason why you want to do this anymore. I mean, unless you have those like generic types. If the destination type was not part of the current crate, then you couldn't implement from directly. For example, take this code. This will fail to compile. Okay, so struct wrapper, so impl from wrapper T for vec T. Okay. This will fail to compile in older versions of the language because Rust orphaning rules used to be a little bit more strict. To bypass this, we do into. So impl into vec T for wrapper T, and then we do that. Okay. It's important to understand that into does not provide a from implementation, therefore you would never be able to do a from anymore. Which means you couldn't do like the error cool thing with like question mark. Examples, string implements into evacuate. In order to express, they want a generic function to take all arguments that can be converted to a specific type T. We can use a trait bound of into T. For example, this function is hello takes all arguments that can be converted into a vec u8. Oh, okay. So not really using that feels like it's less of using like implementing into than for that case. You're just using the trait into as a bounds checker to say like, hey, can this thing be turned into a UA? For example, we did that in the one of the ECS libraries we created where we just like, hey, can you be turned into a string? And if you can, great, we can then do an into on it and he'll be happy. Okay, so we have these required methods. Which is this into. So the into is actually just like perform the conversion, right? So perform the conversion from the input to the self. Consuming the input. Cannot fail. All right, let's find two owned. Okay, so we have this is a borrow, so it's a trait borrow, two owned. A generalization of clone to borrow data. So it's a type of cloned. Well, we've done two owned before. Like we do that on strings, right? So like on a stir, we do two owned and it becomes like a string. So it's sort of like a clone then. Some types make it possible to go from borrowed to owned, usually by implementing the clone trait. The clone works only for going from, okay, a reference of T to a T. To the toOwned trait generalizes clone to construct own data from any borrow of a given type. Okay, so this allows me to like turn one thing, turn a reference of something into a full owned thing. No, because look at this. It's oh, type owned. Yeah. Okay, so it can be a borrow. It could be something. It can be something else. Let's play around with this. This is a borrow to owned. So let's say now I have to implement this on something that I control, I think. Oh, and toOwned also does a clone into. That's interesting. Okay. So toOwned, but it's gonna become a borrow itself. Let's see, what can I do for this? Let's say we do a location and that's gonna turn into maybe like an array. Yeah, that might work out. So let's drive debug to our struct location with this X. So normally we'd create this, we have like our player location. It's gonna be a location with an X of like 10.0 and a Y of like 20.0. Okay, nice and simple, right? Now let's say I have this as a reference. Maybe not even that. If I want to do a toOwned, so impl to owned for location. Okay, so there is only one full one here. So that two cloned, that the clone two, that one is automatically given to us. That's interesting. So okay, I can do any type of owned here. So we can do type owned equals, and let's say I could make this a self. I could absolutely make this a self here. So you're turning this into a location. So in that case, we just do a self. X is self.x, y is self.y. And it's essentially an alternate to clone now. So I can now do let clone to location is equal to like a reference of location dot to owned. And so even if I have a reference of location here, I'd get like a brand new thing because we own this now. And so I can now debug, I can debug location and I can debug clone to location. There they are. Okay, that's pretty cool. I like it. Now, I can also turn this into something else. What if I wanted to owned, now converting this, doing like a from or an into, probably be a lot more interesting. What if I wanted to do this as like an array where we do like an F32 2, and then in that case, you're going to be an array of like self.x, self.y. Oh, the trait staro borrow location is not satisfied. The following implementations are not found. Oh, so do I need to implement borrow to do this then? Hold on, let's try that. Implement borrow. Stop. I know you're upset. It's very upset. Okay, so if I implement the borrow, do I need to do the borrow of? We just did this the other day too. I did it for a string, not an array. Oh, this is just showing like the borrow of here, not like actually implementing the borrow. I can't remember if I need to give it a type. Let's try this again. Can I implement borrow for like that? Yeah, okay, there we go. So now I can create an array of a reference for that. Curious how this is gonna work with the reference for that. So then I want, oh, because I have to like store that inside. I have to store this as an actual like data. It's like the data is going to have to be like that, so that way I'm really just doing a reference of self.data here. So we're borrowing this. To owned is gonna be that. Do you have to be a reference? No, you can't be a reference to that. So I can borrow you, which becomes this data. Oh, wait. Yeah, okay, hold on. Self.data of 0. Self.data of 1. Now you just type 2 owns. Is there a quick fix? Oh, wait, do I have to do a clone into 2? Take this target, which is a self-owned. Oh, and just see, that's why it does this here. So clone into. And you're upset because use of unstable library feature. Oh, can't actually do that myself. Togglebit, hello, welcome raiders. Togglebit, thank you for the raid. How are you doing today? How's your stream? And everyone else, hello. Hi Pizza Wizard, Epic Blarg. Togglebit, stream was good. That is great to hear. Thay Wrapped, Broken Rabbit, hello, welcome. It's in raid and run as always. We'll have a good eating meal. Words are hard right now. Gareth Hubble, hello. Mars Bars. So we are working on today the just sort of like diving into the Rust library and spelunking into it, taking a look around and trying to learn something new. So we're looking into how to implement to-owned, how it works really behind the scenes. And it's an interesting way to sort of like create something from something else. And oh yes, and it is in Rust. Absolutely. I suppose that's a good thing to mention. What is to-owned? So to-owned, you'll often see like programmers do to-owned in like a string, for example. So let's say we want to do like let my hello equals like this string slice, hello world. And then at the end of it, they'll just do something like this to-owned, like that. And that turns it into a string. And you'll see that all the time, which is a lot nicer than a string from, and then the hello world inside of that. Now, we can implement that ourselves. You have any scheduled for more advanced stuff like lock-free concurrency? Yes. Well, schedules may be a strong word for it. Basically, I created like a little Notion document for myself, and we're just going through all this stuff. So most of these things were added in just from us looking through arrays. Like arrays touch so many things behind the scenes that we have to like go through these to fully understand arrays, and then we just sort of like continue on. Now, I try to look into pin and unpin, but because I haven't looked into futures, I got way over my head and couldn't figure it out. So that is like my thing I'm gonna look into later, once I learned about that a little bit more. But yeah, we have a lot of stuff we're gonna be going through. So this is my like ongoing, hey, we're gonna do this until I figure out what else to do. But yes, we're gonna look into that kind of stuff eventually. So what I'm trying to do is figure out how to implement two-owned in like a more interesting way, if that's possible. So let's say like we have this here. We have a location struct that I've created. We have data which is stored as an array internally. So like, you know, the X and Y, 0 and 1 for the indexes. We can borrow that, which gives us just a reference to that array when we borrow it. So that's nice. But if I try to do two-owned, I guess like two-owned would become, a location. No, that doesn't make sense. So if I want to do two-owned on location, then it becomes just a location, right? Which I guess makes sense. I want to do two-owned on this, but can I actually do that on an external type? So let's start this over a little bit. Can I do impl two-owned for, I don't know if I can do like an array of like F32 2 like that. Type owned then would be a location. And then I want to take you're upset. Oh, conflicting. Oh, look at that. There already is a two-owned for this type. For arrays. And I can't actually do that for this other type. So I can do two-owned on a location. Okay, so I can do this for a location like that. And owned then becomes this location. Okay, great. We did this self-owned. So then if I want, we could just say, okay, we're gonna do a self. Data is a, and I guess it's just gonna be a clone, or we're just gonna say data is an array, self of 0, self of 1. Something like that. Oh, self.data. And that technically works here. So we can create this data, we can create this location here, we can even create it as a reference. So this is going to be data is like 10.0, 20.0. So then I can clone that location with a two-owned on it, and that gives us essentially, it's like clone except it's different. Yes, VS Code. I know. And I have Rust Analyzer up, which Rust Analyzer is very aggressive with its pop-ups and everything else. But I do like it, especially for like being able to show off like, hey, look, let's take a look at this and all the examples. I could probably tweak it to like make it not do it quite as fast. Let's try that one. So KJH, you had impl borrow location for F32 2 is the correct order in this case. Okay, so let's try this. Impl borrow, and then the type location in here. So we're gonna do a location for, and then we do this on the foreign type, which is our F32 2. we're gonna turn it into a location. So if we borrow on an array like this, I want to do, I guess this will just create a location, data, self of 0, self of 1. Oh, it'd be a reference. I don't know if I can do that because it's not going to live long enough. Yeah, can't return that. Clone cannot convert from a stir to a string, but toOwned can. Okay, yeah, that's true. Yeah, the Vim extension, I have not used it, but I've seen other people use it, and I kind of like it. It does make me want to play around with it and try it out. Okay, so I can't do this borrow for that because it requires it to return a reference to this, and because arrays don't have that reference or built in, I can't do that here. So I can do the other way where I borrow a location and I get the array back because it's stored internally. So therefore it doesn't go out of, it doesn't get dropped. So yeah, we have to undo that. I keep on trying to like do interesting things, but it just doesn't work out the way I want it to. So this works that way. So impl toOwned for location, so I can take like a location and turn it into that, but I can't do an array like that. Now perhaps I can do, so T has to be the borrowed version and my type has to be the owned version. Yes, I believe so, yeah. Because borrow, you have to return just basically something inside of your type that's a reference. So it has to be like permanently be part of your type here. Now looking at this, like I'm not sure, it basically does a conversion if we want it to, but it has to convert to something that like makes a lot of sense. We can convert this to, I don't think I can convert, let's see, toOwned for location. I could convert this, I think, to an F32 2 like that. Can I do that? No, because it wants to do a borrow behind the scenes. So if I do a borrow location, it has to go backwards. So if I have two wrapper types, maybe I can have them go back and forth here. But not like this. So doing the location manually is nice, and so like if I ever want to do a toOwned, I can definitely do that. It's basically an opposite of a cloned, but I can like do some weird stuff here to like change around. Like maybe when I toOwned it, I also need to like run some kind of like constructor or something else on it, and then that would allow me to do that as well. Okay, so that essentially is our toOwned here. So it's like a cloned, but with a more manual process. Like we can control the clone a little bit more. Although we can implement clone ourselves too and control that nicely as well, but we can clone into a different type. That's the real key here. So allows us to clone, to mimic a clone, to like basically act like a clone, but can turn it into a different type. However, we can only do that if we can borrow that type as well. If we can go the other direction, we'd buy a borrow. Two-owned is basically a generic clone where clone T is T to T, two-owned is T to U. Yeah, yeah, that's what we, yeah, that makes a lot of sense. Thank you, Museum. Also welcome. Okay, so we have these associated types, which is this owned borrow. So we have this typed owned. So basically this is going to be the type that we are converting into as part of the sort of like clone. Air quotes there, because like we turn into something else. Okay, so then we have our required methods. Okay, so for two-owned, we create the own data from the borrowed data, usually by cloning. So interesting, they actually like almost suggest a clone internal. So like S two-owned turns into this like SS, so like from a string or a stir, it both works. And look at that, two-owned V, which is a array slice, gives us a vector. So same sort of like general thing. So basically, it's almost like a convert. So a convert into a type, into an owned type. Yeah, so like just convert into an owned type. Now there's this provided methods, but we noticed that this was a nightly only experiment. We tried to implement it ourselves and it's like, nope, you're not gonna do this. Now this one, clone into, uses borrow data to replace own data, usually by cloning. This is borrow generalized version of clone from. So that might be interesting to play around with once that gets added in. And so what I'm doing as part of this and sort of like deep dive is I'm paying more attention to the release notes. And so if there's anything we've looked at before, then we can now go back and like add that in. So we'll wait until the provided methods actually has something we can do in here. And then all the implementers for it, which we can see stir, C stir, and OS stir, and a path are pretty much the only things that have two-owned on it. I guess like anything that has clone has it on there too, because it just automatically does a clone. So that's interesting. That is two-owned. We've already done try from. Try into. Now try into, it should tell us that we should never do, because it's really the opposite of that try from. But let's go double check. Yeah. So you want to do the try from instead. And that's exactly what it's saying here. So this is given to us automatically if we implement so this is convert try from. Therefore, we should not implement it ourselves unless we really need to. I guess like unless we're using an older version of Rust. That's pretty much like the only reason we learn for implementing into ourselves. If it's an older version of Rust, which in this case means like 1.44, and we need it like on an external type that's not in our crate, that's when you can implement into yourself. But then other than that, just don't. Like, just don't. What is interesting is that this trait is best used as a restricted trait. So like when you're taking in a generic and just saying, hey, you know, I want to take in this like type T, but restrict it to be a try into for this other type. So that way we can like ensure that, hey, we can like turn it into that. So best used as a, what is that called? A restriction? A trait bound, right? Best used as a trait bound when using generics. So, I mean, that's pretty much it that we're gonna go into for this one, because just don't do it is essentially what it suggests. Okay, so we have the associated types. In this case, we have this type error. The error is going to be, well, the error returned in the case that it can't convert into it. So so this is going to be the result. Which I think is just that. So the type error returned in the result of the try into function in the case of an error. I guess like another one is this can fail. So this trait can fail, and therefore will return a result. Whereas the into cannot fail and will just like, if it does for some reason, usually would just crash the program. Like you'd have to panic to exit out of it. So then we have our required methods. So we have this try into, which actually just like performs the conversion. So converts from one type to another, taking ownership of the input and returning a result. Okay. And that's pretty much it. There's not really much more to go about this. It's basically just do the tray front. Just don't. Now we looked at this. How did I copy that? That's weird. I don't want to copy that. Hold on. Default hasher. Whoa, don't minimize. I guess I should look for a hasher. There it is. Okay, so I want you copy the link. So just link to the page. There we go. Okay, so we have a default hasher here. We looked at this a little bit before and we're a bit confused by it. So now we want to actually like truly dive deep. Like what exactly does this mean? So my idea after, oh, this is a struct. Oh, okay. So my idea of like after all this is done, like I'm just doing like a really quick pass through this, like for the first pass. I'm thinking of like creating a series of like the equivalent of like meetup talks, maybe conference talks, probably more of like meetup talks for like some of the more interesting things. And then I'll like maybe so drop around, see who I can like give those talks at, give them here maybe. If you know, if I can't find anybody else, maybe regardless, I'll give them here too. Which will be like the second pass for a lot of these things. Generally speaking, it's how like some of the how I learn is like multiple passes over it to like really sink it in and internalize it. All right, so default hasher. The default hasher were used by random state. The internal algorithm is not specified, and so it and its hashes should not be relied upon over releases. So what is random state? It's also a struct. It's the default state for Hashmap types. Particular instance will create the same instance of hasher, but the hashers created by two different random state instances are unlikely to produce the same result for the same values. Well, that would make sense, right? Random state is like random, right? We can create a new default hasher. This hasher is not guaranteed to be the same as all the other default hasher instances, but is the same as all the other default hasher instances created through new or default. Oh, so if I create two of these together, they're going to be the same. And if we take a look, I don't see like partial equal. Okay, so like there's no partial equal, so I can't like compare them to each other that way. Is debug? Debug, okay, is implemented for it. So we can take a look at it. Let's this is gonna be a default so collections, Hashmap. Okay, so this is gonna be collections, Hashmap, default hasher. So let's do like first, it's going to be our default hasher, new. Let's just debug this out, see what we got. And okay, so we can see here's our hasher. Here's the state that's internalized. It certainly looks random. I don't really know what that means for us. But if I create a second one of these, and we just print them next to each other. According to this, they should be pretty much the same. Yeah, so we have 831, 741. Yeah, so like the internal state is the same. So at least that part is correct, even though it's random. It's the same in one runtime. But if I like quit and run this again, these should be different, I think. No, those are exactly the same number. Yeah, those are exactly the same numbers. But algorithm is not specified, so therefore it could change. So like, even if they are the same numbers right now, they're not guaranteed to be in the future. So don't worry about it. Now, what is this for? I guess like, I don't really know what this trait is used for. If we go back to Hashmap, because like we've used hash maps. Okay, so default hasher used. Okay, let's go to hasher. A trait for hashing an arbitrary stream of bytes. Instances of hasher usually represent data that is changed while hashing data. Hasher provides a fairly basic interface for retrieving the generated hash with finish and writing integers as well as slices of bytes into an instance. Okay. Okay, so I can then do a write out to it. So we can create it. Okay, so we can create a hasher and we can write data to that hasher. And then I can get that out. Okay, so let's try that. So like required methods, there's gonna be this finish. Returns the hash value for the values written so far. So let's get rid of that second hasher. We don't need it. We're gonna put in a finish method here. I guess you need to be mutable. Then we can do first dot. Okay, look at this. We can write all these different things in here. So let's write an I32 and we'll just say 42. And then we'll just immediately finish it, and let's take a look at what this is. Okay, that. Returns the hash value for the values written so far. Despite its name, the method does not reset the hasher's internal state. Additional writes will continue from the current value. If you need to start a fresh hash value, you'll have to create a new hasher. So in all these writes that we have in here. Now, if we take a look back at our default hasher, I guess what we need, it's part of Hashmap. Is this what Hashmap is doing behind the scenes for storing it in memory? Like storing the values of the data in memory? Let's take a look at the implementation of Hashmap itself. Are you using a hasher? Okay, so random state. Okay, look at that. Hashmap, key value, random state. Hashmap with capacity and hasher. So I want to see insert. Values mute. Actually, you know what? It's gonna be easier to find it in here. Because there's new. I don't remember having to do this before. The Hashmap module is just where it lives. This is re-exported to in an easier place. Hashmap is parameterized with a default hasher, which happens to be SIP hash. The current Hashmap is actually just a hash brown Hashmap, an external crate. Oh, really? I didn't know that. But parameterized with SIP hash has the OLE 1.0 interface. So I don't know anything about that. If I bring in Hashmap, so let my thing. Oh, old. Okay, I thought maybe like OLE was like some special thing that I had never heard about. Okay, so let's like, I don't know, data is like a hash map. So it is collections hash map like that. Now you need, oh, come on. I know I'm not done yet. Rest analyzer, stop. Okay, you can just be happy down there. You can just change the hash for hash and somebody faster. So that could be really interesting for like game development, because like so often I'm using hash maps for like easy lookup of grabbing things out, but then a faster hasher might actually be nice there. Okay, so if I put like a key value, so let's say we have like a string, I don't know, a I32 for some reason. Now, I don't think I can tell you to use like default hasher, right? This isn't really saying setting that up. Like I can do new. Yeah, okay, look at that hash map. So I don't set what that is here. So are you happy with that? You are. Okay. So then let's not worry about these. So if I want to like then put something in here, I'm gonna do, oh, data, you have to be mutable. Data dot, we're gonna insert our key and values. That's just gonna be like, I don't know, hello. Oh, I guess we could just do an into world. And let's debug data. Oh, I did say an I32. I totally forgot. You'll be at 5. So, I mean, we see that in here, but we notice that we can set what that hasher is right here. And if I use random state as the default one, or I guess, yeah, default hasher, I think is the same as the random state. Yeah. So I can choose a different one, which would be interesting. But I don't really know what the ramifications are of that now. but I'm still trying to find insert in here. Capacity, values, error, mute, length is empty, drain. There's so many inserts in the documentation that it's almost unhelpful to just search for that itself. There, okay, there's entry. We might come, okay, here it is, insert. So let's go look at the source code for insert. Okay, so we do self base insert. Great. Base. So use hashbrown hashmap as base. So then we almost need to go look at hashbrown hashmap. So can I actually search for, what is it called? Hash_map. From hashbrown. I cannot. So that's an external crate, you said? So here's this hash map. So hash map like that. It should, I mean, I guess it's the exact same thing that we're doing. Now the question that I have for this is, how can I find out what it's really doing behind the scenes? I guess we have to go look at hashmap insert to see what's really happening here. So insert. Okay, so inserts the key value pair into the map. Okay, so we have this hash. Make insert hash. Key and S. We use hash builder. So then table get mute hash equivalent key. It does a memory replace of the item. And then table insert. Oh, interesting. Burn, hello. Oh, you went through the Flatiron Bootcamp. Welcome. And congratulations for getting through the bootcamp. Oh, the code off with Kyle. Yes. Any thoughts on Clojure? I have not used Clojure, but I know a lot of people that really like it. So I take with that what you will. But like I don't certainly have anything against it. I think it's probably a great language, but I've never used it myself. So I can't really say anything beyond that, that. Let's see. Now this is a hash builder. We can get stuff from it. So they're doing some memory replace shenanigans here. I guess not really a shenanigan because like you're just taking the place in memory and just doing like a replacement on that, which we played around with the other day a little bit. When we were trying to like learn pin type stuff. So it's interesting. So there's all these there's all these rights, but then that's kind of it. So I think this might be another thing where I need to, I don't know if I can truly like understand or like explain what the hasher is until something else. But I don't know what that is yet. So I'm actually gonna come back to here and just say like, I don't know what I need to learn default hasher. I know I need something, but I don't know what it is. Okay, so I wish I could continue going on this, but it's 9:31, which means I have my stand up with my day job coming up very shortly. So I am gonna have to find a, I'm gonna have to take off. So I'm so sorry, everybody. Let's see. In fact, it's close enough that I think I have to do an emergency stream shutdown because it's after 9:30 and I don't have much time before that. So I'm gonna go ahead and give my ending right now. So thank you everybody for hanging out with me today. Thank you for coming with the raid if you were here beforehand. I am doing these streams every Monday, Wednesday, Thursday, and Sunday. I know it's a bit of a weird time right now, but that's because I have like early work meetings on Tuesdays and Fridays. So I'll be back here on Wednesday morning, and I think we're gonna start off, unless something else comes up, with Unsafe Cell. And we're gonna see whether or not we can dive into that, which will be interesting. And then it sounds like we're gonna go into primitives and just like whatever we haven't gone in there yet. So anyways, if you enjoy this and you want to get more notifications when I go live, then I would love it if you followed. Otherwise, have a great rest of your day, and I'll see you all online somewhere sometime. Bye.